So today we're going to look into rate of reactions, and we're going to look at the factors that affect the rate, its collision theory, and we're going to look at some experiments. So this video may be a little lengthy, so let's just dive right into it. What is the rate of reaction? The rate of reaction is simply the speed of a reaction, how fast it occurs. Now, is there something that affects the speed of reaction? Yes, there are. There are actually a number of factors that affect the rate of reaction. Those factors are temperature, concentration of reactants, surface area of solid reactants, presence of catalysts, and light. Now, these first four are extremely important in this chapter. Light is not really focused much on in your IGCSE. So, there is a very simple explanation for each of these, and I believe that this is a chapter that most students actually enjoy or will find it easy as compared to everything else. So let's look into temperature first. The simple fact is the greater the temperature or the higher the temperature, the greater the rate of reaction. This is very important for you guys to know. The higher the temperature, the greater the reaction, the faster the reaction occurs. Now, why is that? It's because when you raise the temperature, the particles gain kinetic energy, or they gain energy. You can write kinetic energy, you can write just energy, anything is acceptable. The particles gain kinetic energy. And when they gain this energy, they move faster. As they move faster, they collide more often, which means you have more frequent, successful collisions. And because of the increased frequency of these successful collisions, your rate of reaction increases. And another point that you need to write, and by the way, this is a very common question in your paper 4 exam. It comes for 3 marks. They ask you, why does the reaction rate increase when you have higher temperature? So you're going to say the particles gain kinetic energy. That's 1 mark. And when they move fast, that causes them to move faster and collide more often. That would be 2 marks. And your 3rd mark would be a greater proportion of particles has enough energy to react or for the reaction. Again, they're going to ask you how does increasing the temperature increase the rate of reaction? The particles, they gain kinetic energy, which causes them to move faster, which in turn causes more frequent collisions, and the more collisions that you have, the greater the rate of reaction. In addition to that, you have to write this 3rd mark you will only gain by the use of the words a greater proportion of particles has enough energy. It is very important, and they specify this in the marking scheme, so I've basically given you the answer you would write for this 3-mark question. Now, the next factor is concentration of reactants. Now, the fact over here is the greater the concentration, the faster the rate of reaction. The faster the rate of reaction. Now, why is that? This, let's assume, concentration isn't a liquid, okay? But this is just a diagram I'm going to use to explain to illustrate how the particles would be in a concentrated and a not concentrated solution. So here is your non-concentrated solution. And here, in the same amount, this is the same dimensions, let's assume. This is your concentrated solution. What's the difference between these two? Not concentrated and concentrated. The particles here are closer. So this means that you're going to have more, obviously you're going to have more collisions over here than you would have over there, because here they do not have as much space as they do in the not concentrated one. And if they don't have that much space, then they're obviously going to end up colliding. So when they ask you how an increased concentration causes an increase in the rate of reaction, there is, again, this is your collision theory explanation. A greater number of particles per unit volume. So for each unit of volume, there is a greater number of particles. And because of that, particles collide more often. Increasing the rate of reaction. Again, the more successful collisions you have, the greater the rate of reaction. So when they ask you for this, for the explanation for this phenomenon, you have to say a greater number of particles per unit volume causes more collisions, more frequent collisions, causes particles to collide more often, anything within that area, which increases the rate of reaction. The next one is the surface area of solids. Now, if you have, these are 2 lumps of calcium carbonate, for example. And I decide to turn this into powder, I don't know, using mortar and pestle, whatever. And then it becomes powdery like this. This is powder. Calcium carbonate. Which one would you use to ensure that you have a fast rate of reaction? If you look, now usually how they confuse you, when they say large lumps of calcium carbonate, large lumps, when students see the word large, they automatically assume that it's large surface area. That's not true. As you can see over here, the surface area of the powdered form is much greater than the lumps. And the greater the surface area, the faster the rate of reaction. So remember, your solid needs to be powdered for it to allow a fast rate of reaction, not large lumps. You can see visually that this is covering more surface area than this. And the reason behind that is particles all your collision theory is related to particles, okay, you guys? Particles collide with the surface of the solid. And the greater surface area, the more particles can collide. So over here and over here. Here, for example, you are only getting 2 particles colliding. Over here, you're going to get 1, 2, 3, 4, 5, 6, 7. This is the visual illustration of what's going on in the collision theory. So the particles, they collide with the surface, and the greater the surface area, the more particles can, the greatest the surface area means greater number of particles colliding, which increases frequency of collisions, which in turn increases the rate of reaction. Okay, so we've covered temperature, we've covered concentration, and we covered surface area. Let's move on to catalyst, which is very important. The definition of a catalyst, and this is important because it has come in your paper for exam, is that it is a substance that increases the speed or rate, whatever you want to say, of reaction. And you must also mention that it remains chemically unchanged. This is very important. It's always a 2-mark question, the definition of a catalyst. Why? Because they want you to remember that it remains chemically unchanged. A catalyst does not take part in the reaction. It only increases the speed. So whatever mass you put in, whatever solid you put into the reaction, its mass will remain the same after the reaction is over because it's not taking part in the reaction. It is only increasing the rate of reaction. And all you need to know for a catalyst is that what it does, it lowers the activation energy. It lowers the minimum amount of energy required for the reaction to start up, basically causing the reaction to start faster and therefore increasing the rate of reaction. Now, there is a specific catalyst you guys should know for IGCSE, and those are enzymes. These are biological catalysts, and they become denatured by heat. Enzymes are proteins, you guys. They're biological catalysts. This is basically within our bodies, the reactions that occur within our bodies, and enzymes, they're biological catalysts, so they increase the rate of reactions within our bodies. However, they can only work at a specific temperature. You guys should also know what catalytic converters are. This is just extra information. This is not exactly related to the rate of reactions, but since we have touched upon catalyst, let's cover all its points in one go. Catalytic converters are basically, it's what they do. They're usually in your car exhausts, or they're installed in cars. And there are actually law to be installed in most countries, so a car cannot not have a catalytic converter, because car exhaust fumes contain gases like carbon monoxide, nitrogen monoxide, and unburned hydrocarbons. And what the catalytic converter does is that it transforms them into less harmful products like CO2, N2, and the hydrocarbons turn to water. So carbon monoxide is obviously a lot more deadly than carbon dioxide, so you would rather have carbon dioxide over monoxide anytime, any day. Nitrogen oxide, it causes acid rain, and so it's turned into nitrogen, which is a common element of air. It's, I think, about 78%, I'm not sure. And hydrocarbons also form water and carbon dioxide. You can also do carbon dioxide. So you're going to have to know the reactions for these. Carbon monoxide plus O2 gives 2CO2. Carbon monoxide plus oxygen gives carbon dioxide. And nitrogen monoxide would give nitrogen and oxygen. Okay, light is, again, not that important. It's basically the same. You don't need to know the collision theory behind light, first of all. And it's basically, heat is one of the energies that increases the rate of reaction, and so light is also one of the energies that increases the rate of reaction. And basically, there are photochemical reactions, so there are reactions that are affected by light. And an example of that would be photosynthesis. So basically, they're going to give you a photochemical reaction, and they're going to ask you, why is it increasing the rate of reaction? And it's going to be some kind of scenario where you have light. So you're going to say, as it is a photochemical reaction, the effect of light causes it to increase in the rate of reaction. Now, I want to look at a few experiments as well as their graphs, because you need to be able to interpret a graph. Okay, here. This is the graph that I'm doing to represent surface area. Now, say we did two experiments, A and B. Here we have large lumps. Okay, guys, I've decided that I'd go into the details of each experiment in the next video, because this video would be too long for that. And here we have powdered. I want to go through the experiments for each factor specifically, because I believe it can help you for your paper 6. Now, here we have the loss in mass. We have the time. Do not focus on what's on the axis right now exactly, because I haven't told you how we're conducting the experiment. But what matters for you anyways is to interpret the slope. This, I'm going to say, is A. And this... Okay, I'm no artist. Let's just not forget that. Is B. Now, which one is steeper? You guys, it's obviously B that is steeper than A. The steeper the slope, the greater the rate of reaction. Now, as you can see, in the long run, the slope is decreasing because obviously the reaction will be finishing up. It's going to eventually decrease because it has to stop at some point. So in the long run, this is a decreasing slope. But between these two, when you compare it, this B has a greater rate of reaction because it had powdered form of the solid that we were using. And you can see that it's in the beginning that the reaction is fastest. Now, it's the same thing for temperature. You're going to have one reaction go like this, or you're going to have one react. Oh, God. Again, this one has lower temperature. This one would have higher temperature because this has higher slope. So this means this one's faster. You guys will notice that they end at the same point because you're still using the same amount of the reactant. The only thing that you're changing is the temperature, which doesn't affect how much of the product you end up getting. Or you still have the same mass of whatever powdered solid that you have in your reaction. You're going to still get the same amount of product. It's only all that these factors affect is the rate of reaction. How fast? So again, you need to be able to interpret the graph. I'm going to do it one last time with only one so you guys can know it properly. Here you have a reaction. Okay. Oh, God. What? No. Guys, here it becomes horizontal, okay? When it becomes horizontal, it means that your reaction has finished. Okay, by here, almost, your reaction is slowing down. You see when it's here, it's increasing. It's a good slope. Here it's increasing, good slope, fast reaction. So when it starts to curve about there, your reaction is slowing down. And the reaction is fastest at the beginning. So I hope you were able to understand this topic. I hope I was able to give you a few pointers that would help you out. In the next video, I want to go through each experiment specifically and the reactions.